My great pleasure today to introduce Dr. Grant Cool, our featured speaker. Grant grew up in Moosonee, Ontario, a small Canadian Arctic community on James Bay, where his family owns and operates marine, aviation, and remote logistics businesses. Grant got his university education in Ontario as well, an engineering degree from the University of Toronto, and a Ph.D. in Aerospace Engineering from the University of Toronto Institute for Aerospace Studies. In 1996, Grant's first successful business venture exploited the spacecraft design technology developed in his doctoral thesis. The company fabricated components for the International Space Station, various shuttle projects, and participated in component design and testing projects with the Canadian Space Agency and NASA. Between 2005 and 2010, he founded Kivlik Marine Transportation, a marine carrier service to the Canadian Eastern Arctic, and Kivlik Marine Exploration, an Arctic research and survey company that performed seafloor mapping expeditions and marine logistical support for scientist-led environmental assessment teams and the Canadian Hydrographic Service. Currently, Grant is the Chief Operating Officer of Hybrid Enterprises, the worldwide exclusive reseller of Lockheed Martin's hybrid airships. Prior to the establishment of Hybrid Enterprises, Grant was the operations subject matter expert for Lockheed Martin on the development of the LMH-1 hybrid airship. Grant's web talk will include lots of time to answer questions from you. And now, I'm going to pass the show over to Grant. Grant?
Thanks, Jeff, and really appreciate the opportunity to talk to you today about Lockheed Martin's hybrid airship project. Welcome, everyone. Thank you for joining us on this webcast. Really appreciate your taking the time to do that. I'm coming to you live from the Alberta Aviation Museum in Edmonton, Alberta, and it's a really great place. Lots of beautiful airplanes to see here. You can hop in them, touch and feel, and we thank them a lot for allowing us to broadcast here today. There's actually a B-25 Mitchell over there that I'm going to hop in before we're done. But right now, I'm actually standing in front of a Norseman, which is a Canadian-built, designed and built aircraft, and it is the quintessential bush plane. It was designed to operate in remote Canada, remote Russia, even into the far Arctic and into Antarctica. And it was very innovative. The high wing design, the materials and fabrics it was made out of, in particular, some of the features that made it a very, very useful aircraft were the capacity to use skis, wheels, and even to put pontoons on it, the large cargo bay door for loading and unloading cargo. Interestingly enough, one of the most innovative features were the pilot doors, which allowed the pilots to hop out of the aircraft and onto the pontoons after they landed. And it's actually one of the first aircraft I flew in when I was a child. The motivation for this aircraft, it was almost an inevitable aircraft for the time. There were the need to operate in remote places, the need to work on projects, for people to explore and go places where they'd never gone before. They're the same motivations that caused us to develop the LMH-1, to operate in very remote places, but to do it in a bigger way than this aircraft. Now, we're live, and we're going to actually be doing a series of question and answers in a few minutes. We've got a compilation of questions that we've put together, and we'll actually go through those. I've got a few graphics. We're going to be very old school today and use an easel and a pointer just to make things easier on the web software. So if things are a little bit stuttered as we try to figure things out, we want to give you as much opportunity as possible to answer questions. So please start sending those questions in, and we'd be happy to deal with those in a few minutes. Jeff and the team in Ottawa will pass those questions along to me, and I'll answer them. So let's start with sort of the typical questions that people ask all through the time that I've been working on this project. And we'll start with what is hybrid lift. So it remains a bit confusing to some people. It doesn't have anything to do with a gasoline motor and an electric motor. It's not a hybrid electric system. What we in our business we call this hybrid lift. So hybrid lift is a combination of buoyant lift, so the helium in the envelope that that we have, combined with the aerodynamic shape of the envelope itself, those two things combined together, that's what creates hybrid lift. But there's a lot more to this aircraft than just hybrid lift. There's a third element, I guess we should say, to this aircraft that's also hybrid lift, which is that there are thrusters on the side, and those thrusters also give lift like a helicopter. So 3 elements of lift that make it a hybrid. The third element is actually one that we're quite proud of, which is the air cushion landing system. The Skunkworks team put together an amazing aircraft. It's called the P791, which is a combination of all these wonderful technologies. So the air cushion landing system, which operates like a hovercraft, which allows the airship to move around on the ground so that it doesn't require a mooring tower or ropes and lines that you might see on something like the Goodyear blimp. As you can see, it has the tri-lobe envelope design, which is the aerodynamic lift, and of course helium inside the envelope. These thrusters are what really brings it all together. So these thrusters are part of the flight control system, along with the flight surfaces in the tail. And those flight surfaces and the thrusters are in a closed loop with sets of sensors. You can see a pylon up on the top with some sensors on it. So we're talking about sensors for attitude, position, and also wind pressure changes that allow this flight control system to keep the airship in very precise control, allow the pilots to precisely control the aircraft and move it along the ground, and then of course fly it safely in the air in a variety of weather conditions. As a pilot, it's going to make for probably very boring flying. We really hope it's just going to be the sheer awesome size of this aircraft which will make it fun to fly. So let's talk a little bit about that size right now. So we're talking about an aircraft that's very large. So the LMH-1 is going to be, it's about just over 87.5 meters long. So that's 287 feet long. It's about 150 feet wide, just under 46.5 meters, and it's about 23.5 meters tall. So it's quite a tall machine. You can see the air cushion landing system when it's sitting on the ground. One of the features is when it's parked, the nose points down, and that really helps it stay stable on the ground when the wind is blowing. But you can see the air cushion landing system, it also retracts underneath the aircraft in flight to clean it up. A lot of people ask when they look at this envelope and then it looks pressurized, and they say, is this going to burst? And of course, because of the history of airships, they ask about whether this aircraft, the helium could explode. Of course, it can't. Helium is inert gas. It's not going to burn. Will it burst? No. The pressure between the inside and outside, pressure inside the envelope itself, is quite low. The material also is quite unique. It's named Vectran. It's actually aromatic polyester. It's woven in a ripstop fashion so that tears don't propagate. It's extremely tough. It's got polyurethane coatings on the outside to protect it from ultraviolet light, and other types of barrier coatings on the inside to keep the helium from leaking out. Does it blow away in the wind? That's also a very common question. The key to understanding the difference between this technology, this airship technology, and almost every other airship technology that has ever existed is weight. This is a very heavy machine. The LMH-1, when it's fully loaded with ballast, and it's going to weigh almost 100,000 pounds, so 50 tons. A typical airship that you might see in the past, even the current brand new versions of the Goodyear blimp, they only weigh maximum gross weight, some in the range of 20,000 pounds. We're talking about 5 times the weight. So it's a very heavy machine. It's going to be about 7 or 8 tons of weight when it's ready to take off. Of course, with airships, it's one of the first times where our physics from high school actually have to come back to us. There's airships have weight, very low weight, and because of the helium inside the envelope that lifts it up, so the mass may be very heavy. It has a mass of 50 tons, but the weight is very low as it sits on the ground. So no, it's not going to blow away in the wind. Typical operations up to about 50 miles an hour, wind speeds about 50 miles an hour, 40 to 45 knots. Same range as aircraft today. I think I was looking at some specs the other day. The 737s that most airlines operate today have about a 40-knot wind on the ground limit due to the doors and the operation of the aircraft while it's on the ground. So it's very similar to that. Do we need to have a pilot is often a very common question. The answer is yes. And although we're going to certify the aircraft for single pilot operation, the LMH1 for single pilot operation, you know, the rules and regulations around the world will require that we have probably 2 pilots operating all the time for safety, to be sure. In truth, we're actually probably going to have the opportunity to crew with multiple pilots, multiple pilots, because if you think about the airspeed of this aircraft, the maximum airspeed is about 60 knots, very long trips, so well over 1,000, the maximum range is 1,400 nautical miles. It's going to take a lot of time, so you're going to have multiple crews on board, or at least multiple people on board that can switch out. So we're actually thinking somewhere a bit closer to a marine model, or like the models that they used of the airships in the past, where they had multiple crew that would rotate through. Finally, the compilation questions. I'm going to build bigger ones, most people ask, and the answer is yes, we are going to build bigger ones in the future. We're not quite sure what those might be yet. We've looked at some sizes in the range of about 100 tons, and you know, really big aircraft also in the range of 500 tons. Those are markets yet that we have to explore, have to learn a little bit more about, and also there are some technologies we have to develop along the way to ensure that these aircraft are as safe as possible. The process of certification of something like this is very long and arduous. Lockheed started this program over 20 years ago. I've been at the project since the summer of 2010, and at that point in time they were just beginning to create the basis for the hybrid airship type with the FAA in the United States. That was completed in 2013, and the basis for the LMH1 itself was completed in 2014. Those rules had to be created from scratch. A team at the Skunk Works in Lockheed had to create those rules from scratch. This is a brand new type of aircraft. We have fixed wing, we have rotor wing, we have lighter than air currently. We're now going to have a 4th type of aircraft called hybrid, of which the LMH1 will be the first. So I think if the team in Ottawa has some questions now that are coming in live, I think we could probably move to that. And let's turn it back to Jeff so we can hear some of those questions.
You were covering. Let me just, okay. Sound is good, everyone? I hope. Excellent. So, Grant, it's great that you've covered some of the general questions. We do have some specific ones from individuals who are out there in audience land. And the first one is from Katie Wong. And her question is, what is the ramp-up time for general acceptance and usage of hybrid technology? Which industry will adopt this technology first?
So I think I alluded to that a few minutes ago. It's quite a long period of time. So Lockheed's been working at this project for over 20 years. It took a lot of technology development. It also took a lot of time to create the rules and regulations by which it would operate safely. In aviation, it isn't just sufficient to develop a cool airplane. You actually have to make it cool, safe, and efficient so that the market buys it, and also so the regulatory bodies around the world, like the FAA or Transport Canada, will certify it for safe operation. So right now, the remaining portion of that is probably somewhere around 30 months of actually fabricating, testing, flight testing down in Palmdale, California. So we're looking at about another 30 months to get that done. The first LMH1 will be flying sometime next year, so we'll probably see a lot of coverage of that. What was the second part of the question, Jeff?
The other part of her question was, which industry might adopt this technology first?
So it's an interesting question. There's sort of two parts to that. One of them is who will the operators be, and then also the other part is who will the ultimate customers are, because we're the manufacturers. Lockheed Martin and Hybrid Enterprises will be selling these aircraft to operators around the world. We've seen such a wide range of operators really come to us with many different opportunities they're looking at, some for current customers, some with just brand new ideas. But in terms of the actual end-use customers, the ones that will put the aircraft to use, that will charter or fly or pay the operators to do actual work, it's once again a very large range. So anybody with remote projects, so we're thinking of things like the oil and gas industry, the mining industry, and then of course large government operations in places like Canada and Africa, remote communities. Can also see this aircraft being used quite extensively for things like search and rescue, humanitarian relief, scientific study. So the operators we're talking to really have a huge range of opportunities. The aircraft is going to be incredibly useful. We're talking about an aircraft that can land and take off almost any spot on the planet. So you can go from any one spot to any spot on any other spot on the planet, and that's an entirely unique technology. It's never been developed before.
Grant, you made an interesting point about the different applications of the technology. Several of the questions explore specific reasons why the technology would be applicable in certain situations. One of the ones that I understand the LMH-1 has already been firmly committed to is mining. Is there something special about the relationship between the attributes and the characteristics of the LMH-1 and the mining industry that make it particularly appropriate?
Yes, definitely. I think the mining industry, most of the type of resource extraction industries and the energy industries, oil and gas, hydroelectricity and stuff, the biggest part of the issues that we're dealing with right now can be summarized in one word: impact. Impact to the environment, impact to the people who live in those areas. And you know, quite frankly, there's a large project that's going to be happening in northern Quebec, which is likely to be the first place we will see the LMH-1 aircraft or airship flying in full operations, many of them actually. And one of the biggest reasons why they chose to go along that path, to use hybrid airships in their project, was to significantly reduce the impact to the environment, to allow them to operate without a road. Our motto is no roads, no problem, and they really took that to heart, and they're going to build a mine without ever having to build a road. I don't know if many of you know, but one of the biggest issues with mining and energy projects is trying to do everything you possibly can to reduce the impact to the environment. Our rules and regulations in Canada require us, in many countries around the world, require us to make sure that when we're done with these type of projects, that is clean. The biggest way, the easiest way to do that is to just reduce the impact in the first place. And if you think about using something like a hybrid airship to replace a road, you significantly reduce the impact to the environment. So for the mining industry, this is a tremendous opportunity, an opportunity to develop projects where you never have to build a road, and you can significantly reduce the impact to the environment for that project overall.
Right. Another question that I think would be of interest to a lot of people. From what you've been saying, Grant, it sounds like this technology is more appropriate for moving goods than for moving people. Maybe we can get into that particular distinction in a few minutes, but this one question from Michael Zuo is as follows: what is the projected cost per ton of LMH-1?
Sorry, Jeff, I think the connection went out for a moment there. Could you repeat the question?
Sure. Can you hear me now?
Yes, I can hear you now.
Hear and see? Oh. Actually, for the benefit of the audience, they maybe would be interested to know that you're in Edmonton, I'm in Montreal, and our production
Yes.
crew is both in Edmonton and in Ottawa, so we're all over the place.
We're
So this
really
question from
testing the
Michael
limits of
Zuhl.
the webinar concept, that's for sure.
Yes, we are. The question is from Michael Zuhl. What is the projected cost of load lifting capacity of the LMH?
Okay, sorry, I'm going to have to step in here. Jeff, your question wasn't heard again. I'm just going to repeat the question for Grant, okay? It's Danielle speaking. So the question is, what is the projected cost per ton of load lifting capacity of the proposed designs?
Okay, so that the question is about the load, or the cost of operations, the cost of a load. So that's actually not that easy to calculate. Typically, the best way to do that is to do it in a sort of a comparison fashion, because if you think about the distances, what it's going to cost to move a load is very much dependent on how far you have to go, and in the environment that you're operating in, because most of these type of operations are by the job. You do it that way. But let's talk about it in a comparative way. So when we're looking at a remote area, let's look at the remote area parts of Canada like Yellowknife. What we're seeing in terms of cost comparisons is that it's much less expensive than moving things with a helicopter. A helicopter is really the only comparable technology that can go to the same places that an LMH-1 could go to. Now, if we're then going to add in fixed-wing aircraft, which of course you would then have to account for the fact that you need an airport or something like that, some type of infrastructure. An airport is what you would need. You have to take that into a cost. Also, we're talking probably about 4 to 5 times the cost of operating an LMH-1. On the lower end of that, when we look at things like ice roads, temporary roads, seasonal roads, we're actually pretty equivalent to the cost of that, depending on the specific environment. What we're not as inexpensive, of course, as using railway or road where there's a really good truck, where there's a really good highway or something like that. So that's the range of the cost in terms of what we've seen in the projects that we've looked at. So I think that's how we've defined the cost basis. I hope that's a helpful answer.
Well, if Michael wants to have a follow-up, he can get back to us in the chat room.
Absolutely.
In the meantime, let me get to another question. This one's from Daniel Graham. He's somewhere in our neighbor to the south in the U.S., and he's interested to know what job opportunities exist within the Hybrid Airship Program.
I guess in terms of the Hybrid Airship project or program itself, I can't speak for the team at Lockheed Martin, but I know they're developing lots of opportunities there for engineers and other type of specialists. If we're talking about the industry overall, I mean, the opportunities are massive. We're talking about everything from the ownership, maintenance, parts, engines on one side, to the actual pilots, to the mechanics that work on the aircraft. So a tremendous range of opportunities. We're creating an entire new industry effectively, one that we believe inevitably will be larger than the existing passenger carrier aircraft or business around the world, the movement of cargo by hybrid airships, by airships. So we're creating a huge industry. It's really up to your imagination at this point in time. Some of the fields where we're going to be needing people, of course, are more engineers, specifically aeronautical engineers that focus on this type of operations. There are not a lot of airship engineers around there, as you can imagine. The pilots, we're going to need a huge number of pilots. The pilot training opportunities will start in a few years. Initially, we'll be starting with experienced pilots, ones that already have some type of commercial aviation license, multi-engine commercial operations, and then those will be cross-trained to be hybrid airship pilots and captains. But inevitably, there will be opportunities for people to train directly in hybrid airships and get a separate hybrid airship license. In fact, if you go on online and look, there's at least one school in Quebec that's looking at being the first to train pilots. So there's an opportunity there. So anybody who is in an aviation type of business or has an interest in aviation type business really can pursue these opportunities.
Right. So I guess your advice to young people who are interested in getting involved in the industry would be, now would be a really good time to focus your engineering or your AME or pilot training curriculum and get started, because by the time you graduate, there will probably be vehicles out there for you either to manufacture or to maintain or to pilot.
Exactly. So I think, you know, in terms of timing, I think we're very good. It's very good for people to be looking at. And also, if you think about it, there's probably very few people with any specialization in lighter than air or airships or anything related to that. So it's a tremendous opportunity to be some of the first people to do things like that. So you will see operators making announcements here in Canada about operations beginning, and the mine project Quest Minerals in northern Quebec will probably be moving some of portions of its project forward in the next year or so. So we'll see opportunities coming from there for sure.
Another question. This is from Arnie Blarch in Minnesota. Arnie is asking, could there be applications for commuter operations in urban areas to alleviate traffic congestion?
Yeah, that's actually a really good question. Probably not in North America. We still have a lot of place to spread out and move here. But if you look at some of the more congested places in the world, if you've traveled to India, to portions of China and Europe, there are probably some pretty good opportunities there. We are not currently pursuing passenger certification based on the relationship with the FAA and Transport Canada. We're pursuing initially cargo operations. It also seems to be where the market and the customers would really like us to go, to move cargo to remote places. I would like to point out, though, that the LMH-1 is capable of carrying 19 passengers. I have a graphic here somewhere showing that. If somebody will find it to me, I'll be able to show you the layout of the interior of the LMH-1. So it actually has the capacity now to carry 19 passengers. Oh, there it is. So in this front area, so here's the basic layout of the gondola. So that's the structure that's suspended underneath the envelope. So if you look at this, this is the cargo bay. This is the door in the back that opens upwards so the cargo is easily loaded and unloaded. Fuel and other equipment bay here, but there's a large flight deck and accommodation bay in the front, and that area has room for up to 19 passengers. 19 is a number that is defined by regulations. Above 19 passengers, you have to have the aircraft specifically certified for passenger operations. Oh yeah, and somebody just reminded me that all of these images that you see today are in the handout section, so feel free to take a good look at those. And of course, if you have follow-up questions afterward, don't be shy to send those questions. So for sure, opportunities for people. Oh, just to make sure everybody sees it. So accommodation bay up in the front here, 19 passengers. The pilots are in the front, naturally in the front. You can see that clearly. So there is already a potential for 19 passengers in the airship as it's configured today, or it will be configured, and those passengers will typically be in projects. That'll be the workers or the support people moving in and out. But for the future, definitely some opportunities. In fact, I've often believed that as we get to sort of version 2 of the LMH-1, many of the existing LMH-1 aircraft that exist or that are operating in the world today will probably go to those type of markets. Just if you think about, you know, aviation technology, you know, what happened, older 737s, 727s, DC-9s, they moved into different markets. I think the same thing will happen with some of the LMH-1, the original LMH-1 models. They'll go to different markets, and I think that's one where you could see some very definite opportunities to be able to unclog these very restricted urban areas where the roads are full, the railways are full. You can use the third dimension, fly cargo and people, predominantly people, probably in through those areas.
Okay, actually that question came from Yves Thériault from Bombardier. Just to correct the record, the question from Mr. Blarch actually has to do with the infrastructure required to support hybrid airship operations. You've mentioned that the amount of support, you know, conning towers and ropes and mooring stuff and so on, are the amount of fuss involved in trying to secure a hybrid airship to the ground is much less. But what other aspects of supporting the operations of a hybrid airship are envisioned right now?
So I think you know, you've actually knocked off almost everything, as you pointed out. The most important thing to remember is that we're using hovercraft as the landing gear. So the hovercraft in the bottom will allow the airship, the LMH-1, to land on almost any reasonably flat surface, snow, ice, even open water, taxi across those, pull up to a beach or shoreline and unload. So very little infrastructure is needed at the unloading end, the remote end. At the fixed base, the base where you're operating from, you're going to need all the typical things that you would need with an aircraft. You're going to need, you know, mechanics. You're going to need man lift to get up and inspect engines, other pieces of equipment, APUs and other things to power the vehicle when it's sitting on the ground, fueling equipment, and then of course ballasting equipment. One of the key elements for safety is to ensure that you have ballasting equipment, so when the aircraft is sitting on the ground, you can pump ballast aboard and make it very heavy, so there's no opportunity for it to inadvertently lift off the ground. The helium buoyant lift has a lot of advantages. It makes for a very efficient flying machine. The total horsepower of this aircraft is only about 1,200 horsepower, 4 diesel engines, one in each pod. I'll just show this image. So this is a thruster unit. You can see it's attached right to the envelope. What's key to know is there's no internal structure. It's one of the weight-saving opportunities that we took, which is to put no internal structure like many airships have. This 3-part mount is mounted actually right onto the hull of the aircraft. There's a 300 horsepower diesel engine inside this nacelle, gearbox, shaft, and a propeller that actually pitches straight up and down and has full reverse pitch. And the flight control system actually controls that, so it's very efficient also. So the disadvantage of having helium as a buoyant lift is you can't shut it off. So when you're trying to be safe, the most important thing is to put a lot of weight on the airship so that it can't inadvertently take off.
Grant, that design of, it strikes me, of propulsion with the motor that's physically attached externally speaks to an amazing ease of maintenance on this aircraft. If one of those engines goes on the, you know, conks out for some reason, just take it off and slap a new one on there.
That's exactly the mode of operation. You know, it comes off with 3 pins, undo the variety of sets of plugs, and the whole unit comes off. You work on it, repair it in the shop on a stand. You would have other ones standing by to put immediately on. I believe we can do an entire engine change in 90 minutes and be ready to go again. So it's a very fast operation. The units are actually interchangeable too. So other than reprogramming probably the controller inside by hooking it up into the flight control system, that would probably be the only difference. So they're actually interchangeable too.
We have a question from Howard Slutskin from Skies Magazine, Grant. Howard asks, can you update us on the status of the first LMH-1? How is the construction coming along, and when do you expect entry into service, the first flight? Actually, his question was about first flight, but maybe there's a follow-on question about entry into service, actually.
So first flight, anticipating next year sometime. We can't be definitive about it because it is a process of negotiation and testing with the FAA in the States. So we're anticipating somewhere next year, probably a year from now and a bit, a little longer than a year from now, I would suspect, because we have to certify all this componentry first and then put it together once it's certified, and then certify that unit and fly in, that certified unit. So still on track for 2018 to fly, and we still believe 2019 at this point in time for full commercial operations for the operators who are buying the aircraft. With an understanding, of course, that it's a certification process, so there's nothing definitive about it. We're going to make our best effort to make it as available as soon as possible.
Here's a question about aerodynamics. A hybrid aircraft has an aerodynamic contribution to lift that a regular dirigible or a blimp would not. The question is about the extent to which modeling, mathematical modeling and aerodynamic computational fluid dynamics in this kind of study was performed early on in the design of the airship to maximize its efficiency in the air.
I would say that the answer to that is wow. There was so much work done on exactly that topic. Choosing the shape, finding the right shape was a very difficult task. Not only for you know, the variety of speeds that it operates at, that being one of the factors, trying to find that right balance between buoyant lift and aerodynamic lift. But just for a moment, imagine how this is fabricated. This is entirely made of fabric. So it's actually fabricated on the flat, on the ground, lying on a floor inside a very large building, and it's all heat seamed together. So it's like building a very complex article of clothing that you then have to inflate. And when it inflates, it has to be the right shape and size. So this is an extremely complex shape. So not only was there a lot of CFD modeling done to improve the shape, but there was a lot of modeling done to just figure out how to build this actual structure itself so that when it inflated, it was the right shape. It's not an easy task at all. And it's one that really only an organization like the Skunk Works could do with the kind of people that work in a place like that, doing something so absolutely unique.
The next question has to do with the pace of manufacturing once everything is up and running. Is there some projection that Lockheed has made about the number of units per year that might be produced, and will there be a special facility or a number of facilities built in different countries to manufacture the airship?
The answer is yes. There is a very specific facility. It's in Palmdale, California, where the Skunk Works is. That facility has the capacity to build about 4 at a time. So we're talking about you know, 50 per year potentially. Our current plan, though, is to build 1 a month. We know the market is going to be able to absorb that. That actually becomes the bigger factor, not so much Lockheed's production capacity. Lockheed's a very huge company, a very large company. They have the capacity to build many of these per year, you know, 40 to 50 per year. The market, though, is really what's going to drive the rate that it can be absorbed, the number of pilots needed, the number of mechanics that can be trained, getting those operations up and running around the world. The other part of certification, there's type certification, which is what Lockheed has to do, but then there's also operational certification within each jurisdiction. The operators would have to train people, build systems. That's very complicated and it takes time too. So the absorption rate is driven by sort of 2 parts. Lockheed's a very large company and can produce them very fast, but it would be too fast for the market to absorb. You asked about additional facilities around the world. Not anticipated at this point in time, but you know, we believe there's potential in the future for something like that. If you look at the larger versions that we would build in the future, the facility in Palmdale, California is only large enough to build the LMH-1, and so we would definitely have to build a larger facility for the larger aircraft. And that's a very big consideration as part of the evaluation of the project overall and how it would unfold.
Grant, I understand your colleagues at Lockheed from Skunk Works in Palmdale has sent a very brief but very important message. We are hiring.
That's good to know. Thanks, guys.
I hope everybody out there in audience land who's interested in working on the LMH1 is going to bear this in mind. Maybe we'll be able to follow up with the materials that will be made available following the conclusion of this webinar. We'll follow up with some coordinates that will enable folks who are interested to follow up meaningfully and see if they can get their applications to the right person.
Absolutely, and although I've never been an employee at the Skunk Works, I've had the pleasure, I can't be, I'm a Canadian, but I've had the pleasure of working for many years with the people there, in particular the hybrid team, and I can tell you it's an amazing group of people, and it's an amazing place where you do some incredible work building very innovative products. There's really only very few companies in the world that could take on a project like this for 20 years and push it to fruition against all kinds of odds. I mean, we probably all know about the resistance to airships since you know, I'll say Hindenburg. I've probably lost a bet somewhere along the way for saying that, but it's, you know, there's a lot of resistance in the market and just a lot of resistance from the aviation industry for airships to be used. So it's a testament to the team at the Skunk Works for continuing to push this forward, and a testament to the people at Lockheed who believe in this and are going to make it happen. So I'm sure everybody would enjoy working there. And if you haven't had the opportunity to visit Palmdale, California, there's actually a pretty amazing outside museum that has all of the aircraft developed there, the U-2, the SR-71 Blackbird, just a wide range of aircraft that you can take a look at. It's quite an amazing place.
There's a couple of people have asked about the projected lifespan of an LMH1. Obviously, damage can be repaired, and systems within the airship can be replaced or refurbished. But I guess overall we're talking about the superstructure or the parts of the airplane that eventually will wear out and can't be replaced. Is there a projected lifespan?
I think as a manufacturer, Lockheed projects about 30 years of life. That's pretty typical for the aviation industry overall. All of the large companies project somewhere in the range of the same type of numbers. I think it's really driven mainly by inspection processes, by the known life of certain types of materials. But as with most aircraft, almost everything's replaceable in this. Even the envelope is replaceable. We project something around a 15-year life for the envelope itself, where it would be replaced entirely. So you would take off all the componentry and put it onto a new envelope. But truth of the matter is, like most aircraft, you know, through time, almost all of the parts get changed. So I mean, using my imagination here, I would imagine that it's only going to be parts of the gondola structure that would be part of whatever original serial number this aircraft was. You know, if it's serial number 25, if you look 30 years in the future, probably very few parts left. I mean, the engines will have been, tire thrusters will be changed many, many times. The envelope will have been at least changed once, and a lot of the componentry inside. So it would be very few parts, actually, that would last that long.
Grant, what's the projected cost of an L? Let's say you just want, say, 2 for your particular business. What would you expect to pay for per unit for a couple of LMH1s to park out in your parking lot?
Well, hopefully you wouldn't park them. You'd fly them all the time and do all kinds of fun things and make all kinds of money. The basic price is, the MSRP sort of is $40 million, so 2 of them would be 80. And those are US dollars, so a lot more in Canadian. So that's the basic price. We've established that price by taking a look at you know, how much is going to cost us to build an LMH1, and a fair profit on that. So we think it's a reasonable price. The market has actually responded quite positively to it. So, and if you compare it to, you know, similar aircraft of lifting capacity from the various large companies, it's actually quite a bit less expensive. I think a new 737 is in the 70 to 80 million range.
And of course, for operations in the north of Canada, to have an aeroplane that requires a landing strip or a runway, and then a whole bunch of other stuff like a fixed-wing airplane would require, would have a far greater impact on the environment. And as we all know, the north of Canada is it's a vast, hostile, and extremely delicate environment, and it seems tailor-made to be handled logistically by a hybrid airship that is so kind to the areas where it travels.
Yes. A big part of our motivation was to develop a technology which could do exactly those kind of things. Interesting point of fact, when it's colder, the airship will actually perform much better. Improved lifting capacity being, of course, in denser air being the biggest factor.
That's interesting.
We like the cold around here, is what we were saying.
Yeah. Well, of course, you grew up in a pretty cold town of Moosonee.
It's all relative. It's all relative, you know.
Well, it is. And I understand you've been to the Arctic, or to the far north on a couple of occasions as well.
Yes.
Another question coming from Howard Slutskin of Skies Magazine. How many LMH-1s have been sold, and how many years of production does that actually represent?
So we have publicly announced the sale of the first 12. Those I think it will take about 1.5 years to produce all of those, if I'm not mistaken. I think we're making 6 in the first, or 12 in the first 12, or 12 in the first 18 months or something like that. So that's about the first 1.5 years. We have other operators and customers online who just really haven't spoken publicly about it yet, but a company called Straight Line Aviation from the United Kingdom has been the first to get on the order book for 12.
Now that's interesting. I should mention before the end of our broadcast today that, Grant, you'll be attending and participating in our CASI Zero 2017 conference in Toronto. You'll be one of the key participants with a couple of your other colleagues from other hybrid airship manufacturing companies, one Canadian and one from the UK, on a panel that will discuss the various designs and design considerations for these 3 different models of hybrid airship. And so folks who are interested in finding out more about the LMH-1 and a couple of other airships for that matter, and who would like an opportunity maybe to share a coffee with you or sit down and spend a few minutes chatting, we'll have the opportunity to do that at Aero 2017 at the Sheraton Airport Hotel in Toronto.
Absolutely. Look forward to being there.
Well, it's thank you very much for offering to be there. I think we're getting to the end of our questions at the moment.
Okay.
Are there any others that you were hoping we'd ask, or someone would, Grant, that have shaped up in your mind that you'd like to speak about?
I guess the only one that on the sort of list that nobody did answer, but we are often asked if Lockheed developed this aircraft as a military aircraft first, and no, interestingly enough, that's a misconception. Lockheed, right from the beginning, developed this as a commercial aircraft. It has been considered as a military aircraft along the way, but it's very much a commercial aircraft. And interestingly enough, arguably the first aircraft that's been designed from scratch to be a cargo aircraft. If you think of the aircraft that today are used to carry cargo, you know, large 737s, DC-10s, even now 767s and 777s. You know, a lot of all those aircraft were designed as passenger aircraft and converted. This is a original built from scratch, designed and built from scratch to be a cargo plane to move, or cargo aircraft to move cargo specifically. So it was the only one I didn't see in there.
Right. Well, that's an important point. And just as a PS to that, I gather that it is not like a couple of the really big cargo aircraft are. This is not a roll-on, roll-off design, right? The front part is for the pilots and crew and passengers. The cargo would come on and off from the rear of the aircraft. Is that right?
Correct. So it could roll on and roll off from the rear. Basically, the cargo bay of the LMH-1 looks very much like a very large transport truck trailer box, designed pretty much the same way, very wide. It's about just over 10 feet wide, just over 3 meters wide, 3 meters tall, and about 60-some feet long. So you could think of a standard shipping container, one of the large ones. You could slide one of those right inside there. But designed from cargo from the beginning. We've had Caterpillar D6 equipment driving right up into the back to test floor loading and things like that.
Just a couple of last-minute questions here. One is with respect to sales in other continents and other parts of the world. This question is how soon this kind of technology might be available in South America, and would leasing rather than purchasing outright be an option for countries that don't have a whole lot of cash to spend?
Yes, we are selling them all around the world, and in fact, Straight Line Aviation is anticipating operating them all around the world. Almost everybody is. So South American countries, absolutely. I know we've visited there a couple of times to talk to various potential operators, so I think we'll see them coming there. And about the same time frame. So we're looking at 2020, 2021, when commercial operations are fully in swing. You will see airships flying all over the world, not just Canada. We see Canada as one of the first places to operate, mainly because there's a lot of opportunities here. It's also a friendly environment for us to engage in terms of certifications, operational certifications and such. The weather, I know most people see Canada as being a very difficult weather country. It's actually not. The weather is rather relatively benign here. I know I'm going to get arguments all over that, but it's actually...
You've never been a pedestrian, obviously.
In terms of aviation operations, I guess it would be... what was the second part of the question? Lost track there.
This was about whether leasing rather than purchasing is envisioned as an option by Lockheed.
We won't be leasing them. We'll be selling them, but we already know that there are large organizations looking at buying and leasing them. And in fact, I think most operators in the world, lease most of their equipment. It probably has less to do with the availability of dollars and more to do with taxation and other such administrative issues.
Right. Well, I guess this would follow the paradigm that's pretty well in evidence throughout the aviation industry, where so many operators lease rather than own. Precisely for the reasons you mentioned.
Yes, we are seeing that exact same trend. It just makes sense. As I said, it's more about managing dollars and financing, as opposed to some form of capital expenditure versus leasing or something like that. It's the choice is mostly about how you govern your finances and not so much about how they operate. So I guess most of the airlines around the world lease their aircraft, and we're seeing a very similar trend with the customers we're talking to.
Mm-hmm. Here's an interesting question. Some of us, such as myself, who know a little bit about Lockheed, are aware that Lockheed Martin has pioneered the use of 3D manufacturing, of additive manufacturing, as a technique that saves time, money, resources, and provides tremendous flexibility in terms of the final product and embedding sensors and wires and all kinds of stuff. So the question here is, has 3D manufacturing been used at all in the manufacturing of the LMH-1 in any particular area?
Not that I know of, and I could be wrong here, and my Skunkworks friends might chime in here is in a moment, but I don't think there are any anticipated. I do know that in the process design and development, we've used those methodologies a lot to make unique parts for testing or in a variety of ways. So I don't know of any specific componentry that are going to be developed or manufactured specifically for the LMH1. I would anticipate that once we get to production phase, they might find opportunities to transition to some type of that type of work, but none that I know of at the moment.
Right. I've been asked to remind everybody, if in case, or for those of you who may have joined us late, there are a couple of videos that Grant has made available to the audience, and those will be available on our website. I'm not sure if they'll actually be sent just to the participants who we have on record as having participated in the webinar today. In any event, they will be available to everybody. I understand they'll be on the CASI YouTube page as well.
Right. And all of those videos are available through various sources within Lockheed Martin's websites and also Hybrid Enterprises, our website. All of the same videos are available there too. What will be different is that the material that I've used today will be in a handout. I believe it's in a PDF, and at the end of that PDF there's contact information and also website information where you can find a lot of this information, including the latest news as what's happening.
Well, for those who want it hot off the press, before the ink is even dry, I would encourage everybody to come and actually meet you, shake your hand, and get a little bit acquainted at Aero 2017 from the 16th to the 18th of May. And the plenary panel on which you'll be a participant, Grant, will be on the 16th of May in the morning. So I'd encourage everyone to attend that who can. Information is on the CASI website. So I think we've pretty well gotten to the end of our time frame here, Grant. I'd like to thank you for participating in this and talking to CASI members and non-members out there in Etherland. For those of you out there who are not members of CASI, I'd encourage you to become a member. We're thinking that the access to these webinars in the coming months will become a restricted benefit just for those who are members of CASI. So to get ahead of that particular development, I'd suggest joining now and beginning to enjoy all the benefits of CASI membership sooner rather than later. So again, Grant, on behalf of CASI and of all of the participants in the audience who you can't see but who really appreciated your time today, thank you. And I look forward myself to seeing you in a couple of weeks, and safe travels until then.
Thanks, Jeff, and thank you all for joining us. It was quite fun to be here and do this. Don't be shy to get in touch if you have more questions, whatever the methodology that you use. I'd like to thank Holly on cameras, Zach on sound, and of course our producer Fran Yaner for getting all of this together here today. And thank you, Jeff, and we'll see you in Toronto in a few weeks.
Sounds good. So bye all.
Bye now.